So I want to introduce a very important idea for international trade analysis, especially in a general equilibrium context, which is what's known as the relative price of goods. Now, everyone's familiar with prices, and people usually think of it as something like $20,000 for a car. That's what economists would call a nominal price. That is, how many units of the currency, $20,000, for every unit of the product that you're trying to considering buying, or selling for that matter, from a supplier standpoint. But we want to think very hard about, when you buy one good, how much of the other good do you forego in terms of purchase? Or if you're selling from a firm standpoint, if I sell this good, what is that equal to in terms of other goods? Say if I want to buy the other good, or if I'm trying to decide between selling this good or that good that I can produce. So it's probably easiest just to give an example of this. So in this particular situation, we've got two nominal prices for good X and for good Y. The price of X, $10 for every X. For Y, it's $5 for every Y. Now, if you look at this example, you can tell that if I decide to, as a consumer, to buy 1 unit of X, I have $10 that I have to use for that. I could have used that same amount to buy 2 units of Y, because it only costs $5. So if I think about this from the standpoint of Y, if I take $5 and use it to buy Y, I give up the opportunity to buy 1/2 a unit of X. So people make these calculations probably every day without thinking about it explicitly. If I go to a movie and it costs me, say, $10, I may give up the opportunity to go out and buy a meal for $10. So it's the opportunity cost is, if I go to a movie, I give up the opportunity perhaps to go out for dinner if the prices are the same. So in this particular example, we represent the relative price as px over py. That is the nominal price of X divided by the nominal price of Y. So let's go through this in detail. So I'm literally taking the ratio of one to the other. So I'm going to put $10 per X, that's the price of X, and I'm going to divide through by $5 per Y. That's literally what it is here. So we have this complicated looking expression, but you can simplify that by multiplying both top and bottom by the same thing. Okay, so Y over $5 divided by Y over $5 is 1. Okay, that's, you're multiplying both the top and the bottom by the same number. In the denominator, the Y's cancel out, the $5 cancel out, and what we're left with, and the dollar signs in the top cancel out. So what we're left with is 10Y over 5X, just in terms of the algebra, which is equal to 2Y for every X. So if you plug in these numbers and then go through the algebra, what you are left with is that the relative price of X is 2Y per X. So let's back up and think about what we started talking about in the beginning with the intuition. With these prices, if I buy a unit of X for $10, I give up the opportunity to buy 2 units of Y that only cost $5 each. And that's what this algebra does. The relative price of X is 2Y for every X. Now sometimes people get freaked out because they see the X in the numerator here and it's in the denominator over here and they want to flip it. But remember, the PX is $10 per X, PY is $5 per Y. So if you go through this manipulation, you get the expression just as we had expected. Now, in a trade context, we're going to use this concept frequently. And just to give you one further example of where we're going to see that, there are going to be many instances where, again, to continue this example, of 2Y per X, that is to say, X is twice as expensive as is Y. If we were to start out with 100 units of X on hand, and for every X we earned enough money to buy 2 units of Y, then what you would see is there would be this relationship that you could graph that reflects this relative price. And that relative price is the slope of this line. If we have Y and X on this axis, and we have a price line, the slope of this price line is the relative price of X. If we talk about a steeper line, which we will use in a number of different instances, that's going to be a higher relative price of X. For example, if the relative price of X were 3Y of X, that is to say that each X was 3 times as expensive as a Y, which is what this represents. If you started out with 100 units of X, you'd be able to get all the way up to 300, a steeper line. So that is a trick that we'll be using any number of times, where essentially the steeper this price line, the higher the price of the good on this axis. So this is a very important relationship that we'll see any number of times, so we need to become very familiar with this.